Chapter 7 looks easy, starting off with organizing objects using a new scene class, which will hold all ray objects and lights. Then I add a default scene composed of a light and two nested spheres. Next, I need to move the global intersection tests previously created into an intersections method of the scene class. I then add a static instance of the scene so I can grab the scene from anywhere in code. Since we'll only have one active scene at a time, it makes sense to go with a pseudo singleton route. I'm not yet doing unit testing. That's going to come later in the video when I decide to make the switch based on a recommendation from Ryan Hagan. Here I'm making sure that the new intersection method works with our scene class and all the stored objects. I go ahead and make it part of every array objects constructor to add itself to the current scenes list of array objects. And I do the same for the light class. I have to do some cleanup in the old code to make sure that things compile and use the new scene class. Checking the output, everything looks good at the moment. I'll need to sort those intersections in the future. Now comes the time to add NUnit to my project so I can really start unit testing. I spend about 20 minutes watching a few videos and reading a little bit about unit testing online, but I'll admit, I didn't really learn much, so it takes me some time to get used to it. I make a folder to put all of my unit tests inside of. I go ahead and try out an example by unit testing the dot product from Chapter 1. I add a new class specifically for Chapter 7 unit tests. I'm trying to figure out what assert does and everything that's actually available to me through that class. I make some getters to access the elements of the scene to perform my tests. Next is testing that the default scene is correctly set up for all the objects, lights, and materials. I notice that only the child class sphere has matrices, which I move to the parent ray object class. I get an out of range error. Looks like my arrays are not being populated for some reason. You'll notice everything is through the static member current scene. This is the start of the problem. If I try things again, they seem to work. What I'm not understanding yet is that unit tests run together, and without any kind of order specified, I'm not sure what happens when, and this causes several issues with my static member, which gets initialized over and over again. I realize I don't have equality overloaded for several of my classes, and add it to work with floating point numbers using my utility class from the first video. This test isn't foolproof because I assume it is the correct type of object coming into the equality method. This is going to get me later. Apparently, I forgot to set my color value in the material constructor, and that's causing a problem. I use different default values in my scene materials and change them to what the book actually has. I also forgot a value when creating a new material. The matrix looks good, so I assume my equality test is bad. I copy the color equality check and rather than use a loop, manually check each element of the matrix. I also add this to the mat3 and mat2 classes. Now to test intersecting the default world. I'm not getting any intersections, and this is because I still haven't fixed the issue with my static current scene element versus the scene variable I'm storing here. I realize I can debug a test and do that to step through what is happening. Notice that there are no objects or lights in my scene. Even when the objects are created, they are still not being added to my scene, and that is because objects are added to the current scene, which only gets set up once. If more than one scene is created through multiple tests, the subsequent scenes will not get any of the generated items, and it's going to fail. This is when I decide to do a safety check and see if the current scene is null, in case I have conflicting test cases. I decide to look up how I can structure the order of unit tests and find it is easy to do with the order attribute. Something I forgot to do earlier was to sort the intersections based on their t-value. Here I'm making a simple sorting algorithm that iterates through the list, looking for the next largest value. I make a small error at first, but fix where the value is inserted shortly. And with that, I pass all of my tests. Computations are defined next, which will be a class holding most of the information we need to know when performing the shading algorithm. It holds the intersection value, ray, point, eye, and normal from the intersection and the ray. It's able to generate, just from the intersection and ray, the intersection value, the ray, the point, the eye, and normal. I notice that the getNormal method isn't part of the parent ray object class and I can't access it, so I move it there and make it abstract so all of my future ray objects must implement it. I move the hit method over to the scene class so that I only get the closest t value that is greater than 0. The null reference exception is because I made an equality check dumb, and assumed it always compared points to points. Here I was trying to compare a vector to a point. Another test passed. Unit testing can be satisfying. Now a special case needs to be made if we are intersecting from inside a sphere, which will have a different computation for the surface normal. Instead of pointing outwards, it should point inwards. A Boolean value is added to the computation to flag if we are inside. Shade Hit is going to use the computations to determine what the color should be at that intersection point. I first go back and look at how I implemented this before, using the RayObjects lighting method. I also iterate over every light in the scene in case there are multiple sources and sum them together. My unit test doesn't pass, and I have a sneaky suspicion it is because I didn't use the book's default values for my materials. I also need to make sure the scene's one default light matches the book's values. Ray miss color is important because at the moment we're not properly handling whether or not we miss an object. I'm also going to add two other tests, one for hitting an object and one for when you're actually inside of an object and you've got hits behind you and in front of you, which requires proper sorting. Ray miss fails because I didn't handle the case of no intersections. I exit the method early and return black. Now we're into transforming the scene based upon a camera's perspective, using a from, to, and up vector to determine a transform. This means a new camera class, which is going to hold a matrix for the camera's current transform. The inverse of the camera's matrix will be used to move the entire scene to the correct location. I mix up the subtraction and reverse the order of the terms. I passed 2 of the 3 tests, except for the arbitrary rotation. I check online to see if there's any errata, because so far my matrix math seems pretty solid, and I find nothing. I make sure to normalize my vectors in the view transform method, and this does help a lot, but not completely. I'm still slightly off. I decide this is as close enough as I'm going to get, and move on to the next section. Now it's time to flesh out the camera class, taking in a vertical and horizontal resolution, as well as a field of view. This information will be used to calculate ray to pixel values in the future. The test passes just fine, and I move on to the transform of the camera. Calculating the pixel size is critical in determining the direction of each ray being cast for each pixel in the resulting image. I decide to make the half sizes read-only since they are dependent on other parameters. I should also go back in the future and make sure any changes to H size, V size, and the field of view recalculate these dependent values. Rookie mistake here. I forgot to pass out the variable in the property. Whoops. Ray for pixel is going to generate a ray based on a specific pixel value in our image. We'll iterate over the entire image, calling this method each time to get a ray, and then using that in the intersection test before finally calculating the shading information. I failed this test because I messed up copying the values from the book. Simple as that. I'm nearing the end. Here I'm going to test out 1 pixel value. I copy the old rendering code into my new scene render method, which takes in a camera as a parameter. I keep the canvas and the double for loop, but pretty much everything else can be replaced with the new methods I've created. And we've passed the hardest part. Everything is now in place to take on the end of the chapter goal. I want to see the results of my tests as an image, so I create an instance of my test in my main program and save out the canvas. Interestingly enough, it's only a 5 pixel large sphere. Putting it all together creates a scene with what appears to be a floor, 2 walls, and 3 spheres. I foolishly try to render a 1024 by 768 image with a 0 field of view, which you know is going to cause problems. After waiting quite a while for it to render, I end up with an entire image of 1 solid green color, thanks to the 0 field of view. I change that field of view value, however I forget that it should be in radians and not degrees, and once again I mess up. Third time still isn't right, and it turns out I copied some of the wrong values, and I also forgot to even put in the right wall. This time, everything is upside down, which makes me think something is wrong in my code to export out the image. Before I had to flip everything vertically to make it work. Now, with the camera in place, I can safely remove this from my save method. Problem is, I forgot that I was also using my default scene, which has the extra spheres. I create a new method that lets me clear out all existing objects, since I'm probably going to need it sometime in the future. Now it's time for the final long render at 720 by 480 pixels. It takes a while, but I get this beautiful ray traced image of my scene. Finally, everything is starting to come together. In the next chapter, I'm going to tackle the shadows and make sure that the spheres just don't appear to be floating in the air. If you're following along, please let me know how you're doing below in the comment section. So long, goodbye.